Virtual tour through an Envitec Biogas AG biogas plant. Biogas, environmentally extracted from renewable raw materials and organic waste materials, is the basis for the only regeneratively produced electricity which is, to a large measure, continuously storable and can be variably produced. In the process, the combined heat and power unit within the biogas plant creates not only electricity, but heat, which can be used in a variety of ways. An alternative to the production of electricity and heat is the upgrading of biogas to biomethane, which is supplied into the natural gas network. Regardless of where an Envitec biogas plant is operated, the basic principle is relatively simple. Renewable input materials from farming, animal manures and waste materials from the food and agricultural industry serve as input materials. Maize silage, among other things, is used as input material in this plant. The maize is supplied to the biogas plant through an acceptance bunker using a tractor loader. The bunker is designed with a storage capacity of 2 days. The bunker is equipped with a walking floor, which transports the maize silage. Screw conveyors advance the input materials to the mixing container. Other agricultural or industrial byproducts can also be fed into the mixing system through other feeding systems, such as vertical mixers. In addition to solid input materials, liquid components, such as liquid manure, are also used. It's pumped into the storage tank and stored there until it is used. If industrial waste, such as co-products from the food industry, is used, it must first be pasteurized. That means it runs through a process in which the materials are heated to over 70 degrees for a minimum of 1 hour in order to kill bacteria. Heat exchangers are used for this purpose. The hot water required is provided by the combined heat and power plant. A substrate pump advances the liquid inputs into the mixing container in the required proportions. The maize silage is also fed through a screw conveyor. In addition, byproducts can also be fed in through various conveying systems. A weighing system, which is installed below the mixing container, precisely weighs the amounts. The result is a balanced substrate mixture of a consistent quality. Using an agitator, the materials are mixed into a homogeneous input material. This process is normally repeated every hour. When the stirring process is complete, the substrate is pumped into the fermenter through a macerator. The macerator ensures that no impurities reach the fermentation process. The fermentation within the fermenter takes place in a hermetically sealed atmosphere. Bacteria break down individual enzymes and other components. The result is biogas. Average processing time of the raw materials in the fermenter is 60 to 70 days. The fermentation within the fermenter takes place in the mesophilic range at 35 to 38 degrees centigrade. The advantage of this process, as opposed to other processes, lies in the low energy expenditure and higher level of efficiency. A recirculation shaft is attached to the fermenter. The recirculate enters the shaft from the fermenter through an overflow line. From there, it's pumped into the mixing container in order to re-enter the fermentation process. With this technique, liquid input materials which would otherwise be necessary can be dispensed with. Through the modular construction with prefabricated concrete elements, Envitec provides an especially flexible and cost-efficient method of construction for its fermenters, which can be optimally adapted to the requirements of the customer. The internal heating system, made of stainless steel piping, ensures a constant temperature in the fermenter. Submerged, height-adjustable agitators ensure an even substrate and heat distribution in the fermenter. They guarantee the complete and thorough mixing of the mass. Since the agitators are attached by a cable suspension and are not built in, cleaning and maintenance are possible while the plant is running. The fermenter is equipped with the Flexo roof, specially developed by EnviTech, with an integrated gas cavity in which the biogas is stored. In order to guarantee quality and safety, all roofs have a structural analysis for snow load and wind pressure. For the desulfurization of the biogas, atmospheric oxygen is fed into the fermenter by an impeller. The atmospheric oxygen supplied is used by sulfur-reducing bacteria for the removal of hydrogen sulfide from the biogas in an organic way. The material which is fermented out, the so-called digestate, enters the digestate storage through an overflow line. This container is also equipped with a height-adjustable stirring unit, and in Germany comes with a gas-tight roof as standard. The material is stored here and can be used at a later time as a high-quality, nearly odorless fertilizer. All organic acids were decomposed during the fermentation process. In doing so, the nutrients remain fully intact and can be better absorbed by the plants. The biogas arising in the fermenter enters a connecting gas line where the gas is simultaneously cooled and dehydrated. The biogas is constantly monitored for quality through a gas analysis system. Afterwards, it enters the gas compressor. The gas compressor increases the pressure so that the gas can be used in the CHP. Excess gas is discharged through the emergency torch. It's automatically activated if the pressure in the gas cavity of the fermenter exceeds a predefined value or the CHP is not running because of maintenance work. Before the biogas is fed to the combined heat and power plant for combustion, it passes through an activated carbon filter. The filter serves for removing the remaining hydrogen sulfide from the already desulfurized biogas. The concentration of hydrogen sulfide is measured so that you know in advance when the activated carbon filter is fully loaded and must be replaced. The biogas is burned in a combined heat and power unit, which was specifically developed for biogas. The biogas is converted into electricity and heat. In order to minimize noise emission, the CHP is located in a sound insulating cabinet within the plant room. The exhaust arising during the combustion process in the CHP passes through a catalytic converter developed specially for EnviTech plants in order to reduce formaldehyde. The generated electricity is fed to a transformer at mains voltage and then supplied to the public network on site. The thermal energy can be used for heating buildings and stables, greenhouses, or for the heat supply of the entire residential area, depending on requirements and the size of the plant. Part of the heat is then fed back into the process for heating the fermenter. The thermal energy also lends itself to industrial use, for drying, for the production of steam, and even for the generation of cooling. The daily feed rate of the input materials, the feed intervals, and the agitation time can be entered into the process control system and can be changed and checked at any time. As a result, continuous input control is achieved. Faults in the operating procedure are displayed immediately and can be remedied immediately. In this way, the operator of the biogas plant always has an overview of all important parameters and can react immediately. High-quality components and long-term experience in plant construction are two reasons why EnviTech plants achieve an average capacity utilization of over 90%. In doing so, the biogas generated in EnviTech plants efficiently contributes to the sustainable energy mix of today and increasingly tomorrow.